Fully stuff. Hands up who's a front-end developer. Hands up who's a front-end developer.
Get out of there.
You're all sacked. 4.5. I've got 4.5 there.
5 people.
Afterwards we'll allow a fight. We're quite interested to see what happens with front-end development. Is dead. I'm excited to hear what Barney got to say about that.
It's a statement.
Right, I'm going to shut up and pass it over to Barney. Thank you.
Good afternoon all. My voice is a little croaky. I've got the coronavirus, so you're probably all infected now. So, front-end development is dead. It's a bold statement. Is it true or not? I think it's definitely, well, you may well have thought, which didn't work. Come on, clicker. Did it work? Hey, yeah, we're just a bit slow. All right, so when you saw that as a title for this talk, you may have asked, what the is he talking about? So the traditional definition of a front end is taken from Wikipedia, is where you have a data access layer and your client-side layer, and they talk to each other. These are usually have been written in different languages for the back end, different techniques, and then it's all displayed in the front end, different methods, and it's all been something we've all been very used to for years, but I really think it's changing as time is going on. Front-end development, is it this anymore? Could it be things like AR, VR, voice recognition? Is Alexa, when you're talking to Alexa, is that front-end development? When you're having a chat, asking it to play things? Don't know, but this is things we start thinking about. But in general, when I go to somebody and say, what do you do for a living? And they tell me I'm a front-end developer. At the moment, most people, what they normally mean is I'm a web developer. This is what I think most of us are doing day to day. We're creating applications that can be used over the web, either through a browser or a mobile device. And what sort of techniques and tools do people use for creating these applications? Well, the most common language that we've all used is JavaScript. We're all using this day in, day out. This started off as a very simple scripting tool in a browser. Over the years, it's got more and more capable. It's also got more and more complicated. You have now got to the point where you can't just use JavaScript. jQuery's gone out the window. We're now using things like React, Vue, Angular, Backbone. Even some of the older or more modern frameworks are all being used. These are using to help you create your UI. But I don't want to get into talking about what you then do, all your build pipelines, your tooling, how brittle this can be. This is a lot of context switching, and a lot of it isn't very reliable at the moment. Well, reliable isn't the wrong word, but it can be complicated to learn and keep up with. So something's come along the last few years that may change, or is definitely going to inspire, the way we can do lots of things. And that thing is WebAssembly. So WebAssembly is going to allow us, without plugins, to create things within a browser that run amazingly well. We can have, I've seen demos of full 3D games, AR, VR, automatic recognition, lots of things. It's amazing what you can do. But what is WebAssembly, you might be asking? I'm going to look at this. So this is the definition for WebAssembly. It's a binary instruction format for a stack-based virtual machine. Your browser runs a virtual machine. Inside that browser, the virtual machine currently mostly translates JavaScript into your UI, helps you generate your HTML, etc. WebAssembly allows you to, is a compile target for languages such as C and Rust, that allows you to create that code in those languages and sends this down to the browser. This format is smaller, so it gets to the browser quicker than your JavaScript. It's in a format that's easier to read for your browser, so it can run faster. This will give you near native speeds. The stuff you can create with this is pretty amazing. So C and Rust, great. WebAssembly, great. How many browsers support this? Well, just about all of them. Any evergreen browser, any browser that updates itself these days supports WebAssembly. So older browsers, yes, they're not going to, but I don't know if you're going to be targeting an older browser. Go back. So C and Rust, I don't know how many C and Rust developers we have here. Not a huge amount, I imagine. I'm certainly not one. So there are other languages that can be compile targets down to WebAssembly. You may know one of these languages. You may know several of these languages. They've all got different levels of usability. Some of these are production ready. Some of them are not. Some of the names are slightly interesting. Okay, so these are all... I don't know what you're talking about. These are all available now. This is kept up to date by a gentleman on a GitHub page where I took this from. And it's ever growing and ever changing. So, a gentleman in 2017 called Steve Sanderson demoed at the NDC. He looked at this WebAssembly and took this as a point to take an inspiration to create a framework, or the beginning of a framework, called Blazor. So Blazor is a framework that uses .NET code in your browser. Okay, well that's where it started. So Blazor allows you to run all your .NET DLLs, everything. It downloads them to the browser where they run at near native speed. So this Blazor framework allows you to create a rich interactive UI with no JavaScript. I'm writing all the code. You can write all the code in C#. You don't have any context switching. You've got the same code on the server side or the client side. It's exactly the same. You've got proper C# class libraries. It renders the UI as HTML and CSS, so it's nice and simple. What are some of the advantages of Blazor? Well, you can leverage all of the existing .NET assemblies. There is a lot out there. This stuff is excellent. You've got performance, you've got reliability, you've got security of these well-used .NET libraries. You can stay productive. You can use Visual Studio. You can use Visual Studio Code. You can do it on a Windows machine, a Linux, on your Mac. It's all there. You don't have to switch. There's a common set of languages and frameworks. The tools are stable. They're feature-rich, easy to use, and they take anything from a home developer to an enterprise developer. You can use it all pretty much for free. Blazor itself is based on components. A component is something such as a page, a dialogue, a small piece of UI, a data form. It can all be broken down into .NET classes that you can write nice and easily. You can define all your logic in the class. You can handle user events in the class. These classes can be nested and reused. They can be distributed as class libraries. They can be distributed as NuGet packages. It's allowing you to get these things out into the world. There's two flavors of Blazor at the moment. There's WebAssembly and there's Server. Okay, so WebAssembly is the initial one that Steve Sanderson demoed. This is where we run .NET code in the browser. Everything is downloaded to the browser. It all runs in the browser. This is great. You get near native speed, and this application just works once everything's there. The other version is the Blazor Server. This works slightly differently. All your code runs back on the server. It uses a SignalR connection to talk using a binary format to your browser, which has got a lightweight front end. This front end is rendered as HTML and CSS, and it doesn't need a WebAssembly supporting browser to run. So this would run in some smaller mobile devices, older browsers, etc., using this way of doing it. The code between the two is the same. It's just C#. WebAssembly. Okay, so they have benefits and disadvantages for both of these technologies. WebAssembly, no server-side dependencies. Once the app is on the client, it works. It runs, everything is running inside the browser. Anything the browser can do, your app can do. Any work that runs on there, the effort, if it's grinding away doing something, mining your bitcoins, whatever, it all runs on the client. You don't need a web server to run this. This can run from a CDN. It just gets deployed as some files through the browser. It's a static HTML page almost. There are disadvantages. You can only do what the browser can do. This all runs in a sandbox, same as your JavaScript does currently. You do need a capable client that can run it. It has to be able to support WebAssembly. The downside, load size is larger. All your code, all your DLLs are downloaded to the client. The tooling support is immature at the moment for this. It is being worked on and is being supported by Microsoft, but it's going to improve quickly. Blazor Server is fully supported by Microsoft and is available now and it's ready for production usage. The download size for this is just significantly smaller. It just downs a little, you get a very small web page that just hosts the initial UI. The app takes full advantage of any capabilities you have on your server. Your server can do things, your app can do things. All your tooling and debugging works lovely in there. It's great. You step through your code, everything is nice and simple. Thin clients, such as browsers that don't support WebAssembly, are supported. And all your code stays back on the server, so nobody can see what you do. The front end there's nothing. It's just literally the HTML and the CSS. There are downsides. This Signal involves a hop to and from the server. Every time you interact with the UI, it sends a message back to the server. The server then processes the message and sends a response back for everything. This means if you've got any browser tabs open, any iframes, any other windows, they're all holding a Signal connection back to the server. There's no offline support because of that connection. If it fails, your app's going to stop working. Scalability can be challenging. Again, it's with the Signal connections. However, using some of the Microsoft Azure Signal backplanes, this can be got around and scale very well. You do need an ASP.NET Core server to run all this. Okay, this page, this component, is the hello world of a Blazor app. This is written using Razor, and here we've actually mixed both the UI and the code behind, so to speak. You can see there is very little here. The very, very top, that's your routing. I go to my web app, /counter, this component will be displayed to me. Components can also be nested within each other, so you can build some however complicated the UI you want it to be. You can see there we've got a private variable, our current count. The data binding between that and that is looked after for you. We register an event. So on click, I want you to call that method. It calls this method. It increments the counter. The counter is updated in the UI. There is nothing else. That's it. That is as simple as it can be. So I'll show you what it actually looks like in the real world. You said hopefully. All right, so what have we got here? So this is the WebAssembly version. So if we were to root ourselves by clicking the counter, see if I can find my mouse. Okay, there is that page that you saw. That is the code for that page, for that component. This is actually made of multiple components. We have obviously the main layout, that also has a nav layout, that has the page layout, all combined within. Your source is just that. Nice bit of, well, I wouldn't say nice, but there we are. And if we click on it, our counter increments. Yes, that's very exciting, you say. Right, here's our page. Here's our network connection. So if we refresh this, you can see here, we're actually loading a little placeholder, and then it's loaded all the DLLs that it requires to run this page. Again, if we now click here, again, click me, but I've lost the mouse, where's it gone? Okay, you see there's nothing, no network traffic going. Everything is running inside the browser, it's completely within the application, it's there. We then have So let's have a look. Where are you? Server-side version. Doesn't look much different, does it? It doesn't. The code's the same. I can share this across. However, if I go to the counter and increment it, it's doing as we expect. If I to load the refresh the page, very little is being loaded. It's still working. You're saying, where's the network traffic? But it's down here. There's a WebSocket talking, sending binary messages to and from the server. These messages actually tell it where it's been clicked, the events that have happened. And what you find is if you look here, for instance, so here's our counter, a little awkward on the side here. You see here, it's just there. There's no IDs for anything, but as I'm incrementing it, they're updating. It's like magic. Okay, so I've got one more demo. This is using very simple. It's very simple, but what I've done here is I've taken the Blazor app, which is hiding itself on my screen. There we go, I think. Okay, and here I have created a Blazor app that's using some sentiment analysis. So I found a pre-trained machine learning model that was trained using Wikipedia comments to say if the comment was toxic or not toxic. That model I downloaded basically comes as a zip file. I then added the Microsoft Machine Learning NuGet package to the application. I then added a line basically in the startup saying, add your prediction engine, 2 classes, one for the input, one for the output. This is very simple. I then, I've used a class I separated out the front end and the back end just to make it a little bit clearer. You can see that later on if you want to. The dependency injection is so easy. It's just you have the class, you tag it with the word inject, and the dependency injection just automatically injected a prediction engine in. I then call it with a click, and it predicts, does an extra prediction. So there's very little code. It took a very short period of time to put together once I figured it out. So in here, you can just stand so if you would take one of these two, for instance, and make a prediction, sentiment is not toxic, and if you've got another prediction, where's it gone? There it is. But it's just showing that I can take a .NET code, I can pull it from anywhere. I've taken a package of machine learning and brought it in. Within just a few lines of code, I've got an application that allows me to do that. No clever tooling, never build pipelines that are complicated. It's very simple. I can take my .NET code. I don't need to context switch. I can create potentially incredibly complicated applications that can run in your browser or using C#, or a language of your choice, I should say. Where's that going to take us? Well, I say front-end development is dead. I don't think it is. I think it's just going to change a great deal in the years to come. There are an awful lot of tooling out now for things like Power Apps that allow you to build some quite complicated applications using drag and drop. There are lots of things happening with machine learning. GitHub being such a large open repository, there's lots of training going on with people just reading GitHub repositories. They're learning, they're training models to understand how code is written and what the requirements are. I could very easily see this in the future becoming, you could almost just tell what your requirements are based on the 5,000 Git repositories that exist that are similar to that. Your code could be generated for you. But I think for maybe a moment though, for creating a line of business application for a .NET developer, Blazor and similar frameworks are going to become very useful and allow you to be very productive in producing a high-class, fully functional applications. And that's basically it from me. Thank you all very much for coming. Does anybody have any questions?
Yeah. You on a single thread, the WebAssembly?
The WebAssembly, yes. This runs, the fully WebAssembly runs in a single thread. The server-side stuff can obviously run in multiple threads.
So .NET is not in C#, you can use like F#,
Yes, I understand, yeah.
So that's the game.
And if you've got the live class, you just bring it in. It's not that standard.
Python, stuff like that.
You can use Python, yeah.
So the download you showed of the WebAssembly.
So the WebAssembly one, for instance, for just a simple page as it was about 4 meg.
How would that compare with one of the frameworks you were a similar app in, say, React?
Couldn't say. But the other page, the server-side one, was 30 or 40K. So it depends, where you're going. Obviously, it's going to depend on what the application is doing and what it needs to do.
I think sorry, go ahead. I think you still have to have, if you want to draw in data from elsewhere, you still have the server client to check going on with you.
Yes. So both the application, obviously, it's very interesting when you actually write the things like that, because your services you write it doesn't look like it's running the server side, for instance, or your web API calls you can use look like you're writing them, and they're just going to be within your controller, but they're not. They're called by the server actually, and then it's filtered back up to you over the Signal R connection. So your client doesn't make the call, your server does. And the WebAssembly version, you can make the calls directly.
From the browser out.
From the browser out to wherever.
What sort of testing pattern? Sorry.
Testing, you can split the class up so nicely. The unit testing is great because everything's just a simple class. You tag things for dependency injection in both the code page and other. So it makes testing very, very simple. You just interface everything up. Testing is great. There are some testing libraries coming out a bit more like Jasmine. They're like, we actually build your components up and then you can test them. But you can do it all super fast. You don't need to run a Selenium test, for instance, to test your components structure, how it's all loading together. You do all that in code, nice and fast.
How long did it take you to get the example running? From picking up Blazor to actually getting something working?
There is, you can, if you install Visual Studio, it'll now come with a template for the Blazor server. The Blazor WebAssembly version, you have to install the manually install the template, but that's literally a question of .NET install template, blah. It's there. Then it's just a question of .NET new, Blazor WASM, creates you a sample application that has API calls, the counter, and routing, and it's just there. It's up and running.
How do you debug it?
Debug it. The server-side stuff is great. You just stick breakpoints in anywhere because there's nothing running here. It's all in the code in your back, and that works perfectly.
So that triggers like a normal .NET application.
Sorry?
It triggers the breakpoint like on a normal .NET application.
Yeah, so you can. Yeah, it's exactly the same. It's just normal. If I bring up. Bring it across. And it's gone too far. Where have you gone? It's just massively scaled itself up. Lovely. That's useful. Right. No. What have you done? This one, please. Okay, so this, as I said, remember I separated out the class, the front end from the back end. So this is the back end for that sentiment analysis. The prediction engine here, I've just inject me one of these. In the startup class we create, I literally say services.collection. If somebody asks for a prediction engine, you give them this. It then loads in the startup, it loads the actual model into memory, ready for use. There's various methods for setting up for the scope of how long you want these things to hang around for. And then these are just the properties. There's no boilerplating for notify property changed and all that. And then this is the method down here for the prediction itself. So you can literally come down, where's the mouse gone? Stick a breakpoint as you would. Well, if I can find the mouse, I'll get it there. It's vanished. Somebody's had it. There she is. Right. So, breakpoint, come in. There we go. So that's running. And there we go. Hit the breakpoint. Bang. And you've got... Sorry? There's nothing on the client side, so to speak. Well, with the client side version, the website, at the moment, the tooling is terrible. To be fair, you're back to your old trying to figure out what on earth's going on. But the server-side one is just so simple. And I think what's the easiest thing is probably to work it all out server-side and port it across.
So on the server side, does it support the service portals?
But so speaking like the progressive web app type things, there is support due to come in for those. So at the moment, no, as far as I understand, but I could be very wrong. This is all quite new to me as well. I just got very interested in it and have been working my way through.
Thank you.
Do you still have to know CSS?
You do have to know CSS. Well, when I say no CSS, you need to know Bootstrap. That's probably the easiest way. Yeah.
Yeah, how do you do all the layout? Styles, layout. Where's all the layouts?
Okay, so basically, as I say, it's all componentized. So I'll show you here's your solution. So this is the solution here. It's just laid out. So that's the page. There's the Bootstrap CSS. Down here, you have a main layout. That's the starting component. Then it has the child components with the nav menu in there. Which just, again, just Bootstrap. And that's it. And this is your initial sort of startup here. It enables the routing. So it's quite similar in some respects to the stuff you'll have been using with React and the likes of that, the way the components are constructed. But it's great. It's all C#. I don't have to context switch anymore. Right. Anybody else?
What about SEO type stuff?
Oh, yes, because, well, the initial, depending on the initial page, you just put the SEO stuff in where you want it. So this page, for instance, so we've got, I'm trying to find it. There is an indexed HTML page somewhere. So your host, basically, yeah. So you can put your code straight in there as you would normally for SEO, or it can be injected with whatever you want. Anybody else?
Does it play ball with existing, say I really like a JavaScript charting library or something, can I bring that in and feed it with data from...
You can, yes. There is full interop available with the JavaScript itself. So for instance, you've got a Google map you wanted to embed into the page, you can do that, yes. Drag and drop requires like JavaScript interaction, for instance, if you want to drop file uploads.
Am I right in thinking you can raise browser events from C#, but the other libraries?
Yes, there's a JavaScript interrupt, basically. It's the IJS runtime you just talk to. Anybody else? Great. Well, thank you very much for your time. Thank you.
Brian's done a great job. Obviously, this coronavirus is, you can hear it. So yeah, thank you, Brian. That was really